out there. That will get things done more efficiently.
Yes, sir. Yeah. So I have a few doubts.
Please.
Sir, we were given in our notes that
Or other parts are okay. You understood SN1, SN2 properly, is what you said.
I think I feel like I understand.
Your teacher has clearly covered the various factors which influence the reaction.
Yeah, like comparison between SN1 to E1, SN1, like
All sorts of comparisons have been clearly covered, so to say,
yes, sir.
including, I'm assuming, what to say,
SNI.
all factors. Basically, the carbon group factor, the leaving
Mm,
group factor,
yeah,
the solvent factor,
solvent, yes.
uh,
Temperature.
nucleophilicity and basicity aspect over there of
Yeah,
the attacking substrate, attacking fellow.
he didn't talk about much about nucleophilicity because we did in alkanes, but then yeah,
But basically,
yeah,
every one of those factors have been covered already,
yes, sir. Yeah.
clearly covered, and you are properly clear with each
So
other.
nucleophilicity, I have like in many questions I've seen like they're asked to compare the nucleophilicity. Like, are we supposed to remember that, or like can we do it with logic or something?
We
Because
can logic. Why should you have to
I
remember it?
wasn't able to like.
Ask the ones where you seem to have an issue where it doesn't seem logical. Then we'll talk. That'll be easiest.
I mean,
I mean, that's where it'll be going now. So tell me which ones you found illogical, so to say.
not that it's like illogical, but like uh,
Rather, something where you felt you had to remember. Tell me where all you had to remember.
sir, for phenol and this, what do you call this? Methanoic acid, ethanoic acid. Sorry.
Phenol and ethanoic acid.
Yes, sir. Sir, I thought maybe because ethanoic acid is a like,
Ethanoic acid, acetate ion, phenoxide ion and acetate ion.
yeah, that, yeah,
So phenoxide ion and acetate ion
yes, sir.
comparison.
Yeah.
Okay, all right. And yeah, I should have. What do you have as an issue there?
I mean,
Which one was given as more nucleophilic or more basic?
sir, CH3 one is given. Acetate.
Sorry,
Acetate ion is given, sir.
has been given as what?
The better nucleophile.
Okay, and which has been given as more basic?
Uh, so I guess it's that one only. 1 second. Sir, it was not in notes. Like, it was in a question. 1 second.
Okay, phenoxide ion and acetate ion.
Yes, sir.
Okay,
Just 1 second. Okay.
so among these two, if we are looking at, let's call each of these 1 and 2. You're able to see my screen, I suppose.
Yes, sir, I can see.
If I'm calling these guys 1 and 2, give me the basic character first.
This one will be greater than 2.
Good. Why is 1 greater than 2?
Sir, because that pi bonds are no, sir. We were given one reason. Like it was. I don't think it's for this one. 1 second.
Why basic character wise 1 is greater than 2? Answer is correct.
Yeah,
Why?
sir. Because it the conjugate acid will be a that will be a strong. Wait, 1 second.
You went in the
Strong.
right direction. Basically,
Yes,
you
sir.
have to compare what you have to compare
The acids of the. Yeah,
and
exactly.
acetic acid.
Yeah, that's why I asked. Yeah.
Among these two, which is a stronger acid? The fellow who's called an acid is a stronger acid.
Yes. Yeah. OH.
It's
CH3OH.
definitely going to be a stronger acid.
Yeah, COH. Yes.
Definitely, that means the complementary fellow is going to be a better base.
Better base. Yes.
So, yes, you're going to be having phenoxide ion definitely being a better base compared to the acetate ion.
Yeah.
When it comes to nucleophilic character, though, it is not about the basic character which matters. It is about which end is going to be attacking. In this here, with respect to nucleophilic character, What is the idea here? What was the nucleophilic order which you got?
Said in the answer,
Mhm.
said it was between four different stuff, but then between these two, we got CHCO minus is greater than PHO minus.
Okay, as a nucleophile.
Nucleophile, yes, sir.
So you think and tell me what could be the problem there? What does nucleophile mean? Do you remember the example or the visualization which we used over there?
Yes, sir, yeah.
What
Beggar.
was the visualization?
Beggar.
Bigger. So bigger, where or what can be more easily approachable for the bigger? In the acetate ion, both of these locations are equally susceptible.
Hmm.
Because you're going to be having perfect resonance, right?
Yeah,
So
between the
because
seeds.
you have very good resonance over there, both of these locations are going to be equally good. In this case here, you have learned electrophilic aromatic substitution,
Yeah,
correct?
yeah.
So now tell me in the phenoxide ion, which fellow is the actual nucleophile? The less electronegative fellow will generally be the more donating one,
Yeah, exactly.
right? In this entire system here, the O minus is the more electronegative guy. Which guy
Yeah,
is the less electronegative fellow?
the pi bonds of carbon.
Pink. So what happens here is this resonance happens, which
Downward from
makes
the. Oh,
each
I
of
see.
these spots better nucleophiles.
Hmm.
That is the main reason why this guy becomes slightly better compared to this, if that excuse is given. But that is not going to be the case in all systems.
Sir, but then, um, 1 second. Here are we comparing the strength of each of the sites or like number of sites? Because both of them would matter, right?
Think of what nucleophilicity means. It is
Approachability.
about comparing the strength of the best set. Okay.
Yeah.
In this here ring over here, you're having multiple locations, which is definitely going to be decreasing the probability. And more critically, each of these, if it's going to be attacking from the ring, that's a fat location. There will be more repulsions. In this case here, when you are having resonance happening here, both of these become equal,
Hmm.
which means the probability factor of having two locations actually gets cancelled out over here. Whichever location attacks, the other fellow will compensate and become the double bond.
Yeah, almost symmetric. Yeah.
So this acetate ion here has major advantages when it comes to the nucleophilic character there, because you're going to be having the two locations becoming equal.
Armated nucleophile.
And when you're going to be having the phenoxide ion is also something which is ambident technically.
Yeah.
It is going to be something where the carbon ending, the ring is the one which is actually going to be, what to say, the better donator.
Hmm.
And while phenoxide ion performs very good, what to say, electrophilic aromatic reactions.
Okay. Hmm.
See, ultimately, I will be very blunt and honest with you here. Organic chemistry is going to be chock full of these kind of, what to say, half-baked logics.
Hmm.
In a sense, I am not even sure whether the answer you gave is correct or not. But if that answer is the case, this will be the logic associated with it. So the problem here is most of this is hindsight. You understand what I mean by hindsight, I
Yes,
suppose.
sir. From the answer getting.
Bulk of the time, it's actually about what you literally said, which is knowing the information and then targeting. I am still not completely convinced whether acetate ion is a better nucleophile, because my brain tells me phenoxide ion and the carbon ending is a far superior nucleophile.
Oh.
Provided the rings, what to say, problems with respect to bulkiness are going to be not taken into account. Because generally, when it comes to nucleophilic character, it is about the fact that that ending is not going to be surrounded by too many water molecules. That ending can comfortably go attack. All of those will matter.
Hmm.
From those points of view, phenoxide ion wala carbon ending, the para location seems quite primed actually. But if you consider the phenoxide ion oxygen ending, that is a problem. That is definitely going to be a weaker nucleophile compared to the acetate ion. But if you do consider the carbon ending, that probably will be better. So I am not particularly sold on the logic which you, on the answer which you just gave. But if that answer is correct, this will probably be the logic associated with it. Now, what other issues? You said you have some doubts. Let's start
Yes,
off
sir.
with your doubts.
One second.
Give me a second. Let me just go pick up some water.
Yes, sir.
Yeah.
Yes, sir. Yeah. Sir, we were given that alpha halo aldehydes and alpha halo ketones are reactive for SN2 reaction, and he gave a reason of like
Mhm.
lowest unoccupied molecular orbitals in
Mhm. Repeat. Alpha, halo.
alpha halo aldehydes and alpha halo ketones are highly reactive for SN2 reaction.
Okay. So this is the species which is given, and they're telling you that this location is very primed for SN2.
Yes, sir.
Okay, that is correct. What was the problem which you have there?
Sir,
Why is that the case?
sir, what?
No, I mean, you have an issue with why that is a reality, is it?
Yeah, they were saying some about like each has like a lowest energy empty orbital, so they combine to give. I did not understand, like, to give lowest unoccupied molecular orbital which has lower energy than the pi star and the sigma star. So we are
Okay, stop. We both know the moment somebody goes there, that basically means they are bullshitting. So stop that and think your own self. That logic is like किसी बुक में लिखा हुआ है, रटा के यहाँ पे मार दिया है, छापा है, वो छोड़ो, तू खुद का सोचो. You are somebody who likes to think. What does it mean when you're going to be having SN2 happening here? SN2 means you need to attack that location.
yeah, 1 second.
So first, let's move into what is this being compared with? What is this with respect to? When you're saying this is going to be doing good SN2, what do you mean by it does good SN2? Without comparing it with something else, there is no meaning in saying this does good SN2. What are we comparing it with?
Normal carbonyl groups.
Normal alkyl halides. Normal
Oh,
carbon compounds don't do goddamn SN2.
not like beta don't do. Wait.
Beta, okay, let's go with the beta. So this would be a beta.
Yeah.
Okay. So I'm going to be having this is the alpha, this is the beta. Okay. Now SN2, what is going to be happening there? Some fellow has to basically come and attack.
Yes, sir.
So listen to me, what are the general factors which matter?
The steric hindrance,
Good. So
leaving abilities.
let's put it as steric hindrance itself. Steric hindrance at site of attack. Okay, what else?
Sir, electron density at the Side to
Okay, let's put it as a delta plus on
yeah.
location. Okay, then attacker, leaving
Lead.
group,
Yeah.
solvent,
Yes. Fair
and
answer.
post temperature.
Hmm. Yeah.
Temperature decides the competition between the
E1 and SN2 and E2.
So now these are the more or less acceptable factors. Now, if you're going to be looking at these factors over here, attacker is going to be something inconsequential when you compare because both will be assumed to be the same.
Hmm.
Leaving group, we'll take it as similar, of course. Solvent, we'll of course make sure that is also taken care of as similar. Temperature will also be taken care of as similar. So among them, which ones are going to be the only factors which are really going to be playing a role? Steric hindrance and delta plus.
Yes, sir.
Now, let's look at the delta plus factor first. That is the easier factor to look at. From a delta plus factor, if you're comparing the alpha halo, beta halo, and a normal halo, forget the keto thingy existing. If you're having a normal alkyl halide type of system, the delta plus on this fellow here, let's call it as delta plus 1, let's put this guy as delta plus 2. Definitely delta plus 1 is going to be higher compared to delta plus 2.
Yes.
So from this factor point of view, it's perfectly acceptable.
Yeah.
Screw all of that, what to say, molecular orbital mumbo jumbo, which was bullshit over there. Now, from a delta plus factor, it is commonsensical now.
Yeah.
From a steric hindrance factor, how would you look at it? Do you think this causes steric hindrance?
No. Wait.
Why?
Because the nucleophile
Saying
is.
why? If you're saying yes, why?
1 second. It'll attack from the opposite side of 1 second.
My question was very specific. Is this going to be causing steric hindrance? The carbonyl group. When you want to check for steric hindrance, how do you check?
Hmm.
You check whether that is going to be sp3 first,
Yeah.
because sp3 means it occupies more space.
Yes.
If the arrows are sp2, they are
Yeah.
flat on a plane. They don't occupy much space,
Hmm. Okay. Okay.
right?
Yeah. Yes.
That means there is room above and below to a good extent.
Hmm.
So
Yeah.
the
Yeah.
carbonyl group does not offer much steric hindrance.
Hmm. Okay.
The carbonyl group offers what though? Is it
Repulsion.
going to be offering any competition for the nucleophile?
Yeah. Because O minus also O will also have nucleophile.
Not like that. I do not mean that.
Oh.
See, this location and this location, these two locations, are they in competition with each other? Because this
Like,
location here also has a high delta plus, correct?
sir, but then there you can. There's no leaving group to leave. No.
See, that's what I'm trying to tell you here. In this case here, in the alpha halo there, the main thing which might happen is that you might have nucleophilic addition happening on the carbon.
Hmm.
Why? Because this location also has the same
Also the
delta.
delta plus. O is pulling the
It
electron.
has a higher delta plus,
Yeah. Maybe. Yeah.
right? So if nucleophilic addition is going to be a possibility, that will possibly be competing more. But looking at nucleophilic, what to say, attack purely from an SN2 point of view. That is, if you make sure that the system, the solvent is going to be a nice polar aprotic type of solvent, which
Hmm.
will increase the nucleophile's tendency to attack as a nucleophile rather than go perform addition. Because in the addition reaction, what will happen? It will basically end up reacting as a base over that. It will be donating. And this fellow will be taking. The oxygen will take it up, correct?
Yeah.
So that is going to be a possible competition. So if you make sure that the nucleophilic addition becomes more difficult, automatically it should not be a problem. Now, one more factor which will basically come into the picture here is this. You learned about SNI is what you told me, correct?
Yes. That's what.
So when you're going to be having SNI, or let's call it neighboring group participation.
Hmm.
वो हो गया कि नहीं हुआ?
Yes, sir. Yeah.
So when you're going to be considering the NGP aspect over here, what happens is this. You can have this bugger going and attacking this fellow
Yeah.
and kicking this fellow out.
Yes.
And then an external nucleophile will come and attack either here or here.
Yes, sir. I had a doubt like in NGP regarding this.
Hmm.
Here when carbon bonds with the say, oxygen will get a plus charge, right?
Temporarily, but it has octet.
Correct. Yes, but then how come the nucleophile won't attack the plus charge there? Why would it go for the delta plus?
Think for a second what I just said. What was the point I said very specifically when you just pointed this out? I said
Okay.
oxygen has octet.
Hmm.
Think along those lines. The nucleophile will attack a site which is losing octet, which has a chance of losing octet, right?
Yes, sir. Yeah.
If the fellow is already having octet, and even when the attack is happening, that fellow will take the octet and only leave. You're basically asking why does it not attack the oxygen over there, correct?
Yeah. Yes.
That's what I'm trying to say here. Oxygen, even if it, what to say, leaves, it will leave with the octet. Who is the guy who gets screwed in the process when the oxygen leaves?
Carbon.
One of the two carbons.
Okay. Okay.
You understand where that goes now?
Yes, sir.
Okay. Next.
Hmm.
I'm assuming your doubt is cleaned here now in this part.
Yes, sir. Yeah.
Next question you have over here.
Sir, regarding this NGP, there's one question was I didn't.
I
Sir,
have a question here for you.
yes, sir.
NGP, what did you learn about neighboring group participation? Actually, you said you have questions on that now. Then I'll probe you there. Chalo,
Sir, it is a reaction.
huh. Hmm. What's your issue here?
Sir, I was getting a different answer. I thought, sir, first the lone pair of sulfur will go to the carbon, which is connected to Cl.
Let's first see what happens first. First, this bugger will attack here as a possibility.
Yeah.
All right, we get an S minus possible.
Hmm.
Then only we start off with what you are basically going with. Now, in this particular case here, yes, this guy can directly attack over here also.
Yeah, that's fine.
Now, let's start off with looking at the location of attack first. What type of a location is this? Is this good for SN2?
It's okay. I mean, not very good because
Not very good. That's the key point here first. It's not that good for SN2. Why is it not that good for SN2?
steric hindrance is at second degree
Steric
carbon.
hindrance is reasonably high.
Yeah.
Right? So steric hindrance is reasonably high. It is not going to be that efficiently good for SN2.
Hmm.
Okay. Now, what is going to be happening in this particular case here if the neighboring group participation does happen?
Lone pair of sulfur will go to this.
Sulfur minus, and that bugger should come and attack.
Hmm.
If that bugger does come and attack, what is the ring size it forms?
It's a bicycle.
No, I did not ask that. I
No.
asked what is the ring size it forms. Forget about the bicyclochrome. When it comes to neighboring group participation, the key thing there is if I'm going to be having different fellows, oxygen, sulfur, halogen, if these guys are performing neighboring group participation, you need to see when that neighboring group participation is happening, what is the size of the ring which is going to be formed. For instance, if I'm going to be looking at oxygen, what is the ring size it prefers to form?
3.
No. 3 is possible. I'm not saying 3 is impossible. I'm not saying that. I'm saying what is the most preferred one? And
Mm,
avoid. Oxygen usually prefers to go for 5 or 6 or 3. Now, among the 5 or 6 or 3, 5 is most favored. All right. And oxygen will specifically avoid 4. Same goes for nitrogen, actually. The main reason being, when you're looking at a 4-membered ring being formed, the bond angle has to be closer to 90.
Yeah.
All right. And oxygen and nitrogen, when they are in sp3, they will prefer to go away from 90. Water and ammonia, their bond
Yeah.
angle is much higher than 90.
Yes. Yeah.
Whereas when it comes to sulfur here, this bugger likes to form 4 members. It has no problem with forming 4 member, because when you consider the H2S system, what's the bond angle for H2S?
Uh, is 90,
Closer to 90,
90
92, 93.
91.5, I think.
So somewhere near 90 is the bond angle for sulfur when it is forming the sp3 system.
Hmm.
What happens is sulfur can do 4-membered rings,
Yeah.
but sulfur simultaneously 4-membered becomes better. The other ones basically end up becoming slightly worse off. So in
Hmm.
this case here, if the sulfur is doing the attack, there are two things to consider. First thing to consider, can the sulfur attack from opposite direction in this case? Because this is a ringed system already.
Yeah.
Are they in a direction where you're going to be having the sulfur minus being in the opposite direction of the chlorine? That is one question to consider. Second question to consider, what is the ring size the sulfur is forming when it is performing their attack? And is that ring size a feasible ring size?
Hmm.
Two questions to consider here.
Yeah.
So in this case here, let's have a look here. This is going to be cyclohexane type system,
Yes, sir.
1,4.
Yeah.
So if this guy is going to be in chair form,
Hmm.
what will it be looking like? I think we discussed how to consider chair form, right?
Yes, sir. Axial and equatorial.
Long time back. I think I should have
Yes.
discussed how to flip the thing and run through that. I'm sure your
Yeah.
team in school also has done that, but
Yeah.
I remember vaguely discussing that with you.
Huh.
So this is a planar form here, correct?
Yes, sir.
So in this planar form here, you're being given clearly that the chlorine and the sulfur are on opposite locations.
Hmm.
But this is one, this is 1, 2, 3, 4. Right. So if I'm considering carbon 1 and carbon 4 in chat form, will they be in same conformation?
1 second.
So let's put this as y. This will become inverted. This will become y. This will become inverted.
Yeah.
Right. That effectively tells me that they are going to be in opposite conformations.
Yeah.
And if they are in opposite conformations, that basically means if I take this guy as axial and this guy is equatorial here,
HS will be. Yeah. Good. Hmm.
right? So this fellow will become the equatorial and this fellow will become the axial.
Axial.
So now let's look at the chat form now. So this is my chat form.
Yeah.
In this here, if I'm going to be placing these are the locations.
Yeah.
So now let's place the chlorine here. Where will the fellow be? Chlorine and sulfur will be equatorial, equatorial.
Equatorial. So side.
I have S minus here and I will have chlorine here.
Hmm.
Or I will have S minus above and chlorine in the bottom.
Yeah. Same.
So properly they are in opposite directions.
Yes, sir. Yeah.
So that is satisfied properly.
Yeah.
So now the next thing is only the ring size. So if this sulfur is going to be targeting this carbon, what will be the ring size it will be forming? New ring size. It will be 1, 2, 3, 4, 5 membered
Yes.
ring,
5.
which is not too shabby.
Hmm.
So this should happen. Did you assume it would not happen, or is it given it is not going to be happening?
No, no, no. I understood it happens. Yeah. Yes.
So then it is in sync with what is acceptable. Now, then what's the issue here?
Sir, at the end, like, I thought this OS minus would go and attack the carbon, but rather it was attacking the water and then the water left.
Sorry?
like when I was drawing what is happening, then it was like answer was given such that OH minus will attack the hydrogen of the S. Like they didn't said.
That's what I also went with, na. OH minus can attack here or here. So what did we first consider? Is this location good for attack?
Mm.
Good for SN2 directly. That was the first thing we talked about.
Yes, sir, yeah.
Is this good?
No.
No. Because it is not good, neighboring group participation will happen. And in this case, when the neighboring group participation does happen, we will have a possibility of attack on carbon 1 or carbon 4.
Hmm.
That is, if I'm going to be, say, tagging this carbon 4 here as an isotopic fellow, just to track kahan pe attack ho raha hai. Once I have the neighboring group participation happening,
Yeah.
what will happen? My sulfur would have already formed a ring like this as a bridge
Yeah.
type of thing.
Yes, sir.
Then I can have either carbon 1 or carbon 4. Both of them are going to be capable of getting attacked now.
Mm.
Right?
Yeah.
Because now it doesn't make a difference. Both are equal now. The ring just has to break. Or this system, which is going to be a new, what to say, multi-ring, what to say, or bicycler type of system, will exist as it is.
That's what they say.
So there are two possibilities here. Either the product should be something where I have retention of configuration on this chlorine, and I put the OH on that same location as the chlorine with perfect retention. That is one possibility. If that is given, that is not a, what is a bad possibility. Or I can have on this carbon number 4 attack happening here.
Hmm.
Or I can have the ring, basically the bicyclofellow, just staying as it is.
Sir, without the OH minus attacking, wouldn't why can't the lone pair of sulfur just go to the
It cannot.
carbon?
It cannot. Mainly because the sulfur here is going to be a very poor donator. Think again. Sulfur
Okay.
has extra spaces, it has d orbitals.
Yes, it does.
So if it doesn't get a minus, why would it go and donate? It is already delocalizing its electron density in those places now.
Hmm. Sir, but then does this always happen? Like, should it always for the minus charge the internal nucleophile, or like in
See,
some other
let's
cases
let's
can
let's let's, let's you're basically now coming to a fundamental question. When should you check for neighboring group participation? Correct?
yeah.
That's
Well,
what this question is now coming to
I
us.
think yeah.
So now let me ask you a question here. You're about to start a small business. Okay. Who will you go ask for cash?
Parents,
Yes. Why?
because
Because
they'll give it. I mean,
no, it's not about they will give it. Banks will also freaking give it.
yeah, they can, but
Hmm.
yeah.
Procedure is more. More goddamn legwork has to be done.
Yeah.
So, what's the point which I'm trying to explain here? If neighboring group participation is even remotely possible, it should absolutely goddamn happen. And it will take priority over everything else. Why? Because that is that much easier. The probability of that happening is tremendously higher simply because the nucleophile is part of the same molecule.
Yes, sir. Yeah.
So if you're starting up something small, you will go to your parents.
Yeah.
If you're starting up something medium size, you will go to your parents and your relatives.
Yeah.
Only then you will start thinking about the bank and all of the other thing. Right?
Yeah.
So if a system, if a molecule has something which is, what to say, a site which is capable of getting targeted by a nucleophile, and if the molecule has a nucleophilic end which can act as a good nucleophile on some other part of the molecule, and
Hmm.
they can interact, that is where the ring size comes into play. That is why I basically was very specific about making sure that you are familiar with the ring size as possible. Because The ring size is extremely critical. This ring size is extremely critical. That is going to be very critical. I mentioned whenever you're going to be looking for neighboring group participation, only two factors to consider. Are they in opposite directions? Is the ring size acceptable? Only two things to watch for. So if they are in opposite directions, yes, it can happen. It's like, for instance, you currently will go and ask your parents, because that is the easiest thing to do for you. Because you do not have access to other people.
Yeah.
In your circle who can give you access. You know what you will get from your parents will come with strings attached.
Yes. Yeah.
Absolutely.
Yeah.
But that is still an easier option right now.
Yes.
When you have more options with lesser strings attached, which will you prefer?
The resistance.
Exactly. Right. So it is all about whether the attack is feasible from a standpoint of whether they are in opposite directions and whether the ring size which is going to be formed is acceptable. When it comes to oxygen performing neighboring group participation or nitrogen performing neighboring group participation, they can do neighboring group participation even when they are not necessarily having a negative charge. Why? Because they don't have any
Good.
empty space.
Yes. Exactly.
So their electron density is not delocalized properly. So it's like cash sitting in a savings account being wasted. In the sulfur's case, the cash is there, but it is parked in stocks and bonds and shit.
Yeah.
It's nicely delocalized. So if the sulfur or something which has extra space suddenly gains extra liquidity of cash, then that fellow will go attack. Because that fellow is now looking to park that cash somewhere else.
Yes, sir. Yeah.
You're understanding the point over here?
Yes, sir.
So if the system which is in the molecule itself, which can act as a nucleophile, is something which is going to be not having enough delocalization of electron density, then that system can attack as a neutral species also. That's the case with oxygen and nitrogen.
Oxygen, nitrogen. Yeah.
Fluorine also does that. But if that system has delocalization, then
Negative charge.
you would prefer to have a negative charge.
Yes, sir.
Only then that fellow will become a better system to donate over. That is the case when it comes to sulfur and other systems which are having delocalized, which have extra spaces. But that doesn't mean the ring size should not be looked at. Ring size has to be looked at, and opposite direction has to be looked at. Those are definite factors. Other than them, this factor will come into play. Those two are the primary factors. You have to have the lone pair or the particular donator being in the opposite direction of the leaving group. That is first. If that is not satisfied, it will not happen. Second, ring size. Usually the ring size will take into the account the other factor also. The first factor will generally come into the ring size part over there. Okay, now what's your next part issue here? Now, the real question you should have asked over here is, how do you get the answer? How do you judge the answer in this kind of a question here? That is going to be the really tricky part here. If this question was given as a single option correct question, and what to say, the options given are not going to be having any of the funny answers, funny options I mentioned. When I mean funny options, if they have not given this chlorine here to be, what to say, or the nucleophile attacking on this carbon and retaining the location there. If they've given hydrogen, what to say, if they've given that the axial location is going to be taking the nucleophile there, you can happily say that is not going to be happening.
Okay.
But if the question option is single correct, and they have given you the ring formation over here as one product, and they have given you this chlorine getting replaced,
Hmm.
and they've given you this chlorine getting replaced perfectly and retaining location over there. Or they have also given you this carbon as an isotopic carbon, and they have given this fellow also having a nucleophile possibility.
Hmm.
Then all of those are going to be tricky options. In that case, you have problems in deciding what to mark over there if it's single correct. Usually, if they give you this kind of fellow here and they are sensible enough to mark this as what to say isotopic there, it will be more than once a correct question.
Hmm. Yeah.
In which case, you will have to be very careful and mark all of those possibilities because all of them will work excepting what to say inversion at this location. At this carbon, if inversion is given, you avoid that like a plague
Hmm. Okay.
because that will mean direct SN2. Direct SN2 is the least favored.
Yeah. Hmm.
Now, what were the options given in the question here?
It said there was no options.
There was
There were no options.
there were no options. Then you can basically go for all of them. Logically speaking, you have to give all of them as possibilities. And in this particular case here, yes, the neighboring group participation will absolutely happen. It
Hmm.
satisfies the conditions for neighboring group participation to happen, so definitely have a chance of happening.
Hmm. Yes. Okay. Okay.
So is this puzzle cleared out?
Yes, sir. Yes. Got it now.
Okay, next one.
One
Neighboring
sec.
group participation level. Let's finish off the ring sizes here. Sulfur can
Four,
form
five.
four membered.
Yeah.
This is one of the few fellows which can form four membered, mainly because the bond angle which sulfur goes for is closer to 90. When the bond angle is closer to 90, it can bend properly and attack from the backside when it is forming a four-membered ring. Oxygen, nitrogen, and halogen cannot do that.
Hmm. Okay.
Halogen also can do neighboring group participation. Halogen will prefer three-membered rings. It can do five or six also, but it will prefer three-membered more. And if I'm going to be having, say, benzene ring, this guy can also perform neighboring group participation. It will
Yeah.
prefer three-membered rings. And if I'm going to be having, say, acetate ion type of system, this fellow will also prefer to form three-membered rings. That is like this.
Hmm.
So you'll end up having oxygen when it is in the form of partial sp2 type of system. It will prefer to form a three-membered ring. And halogen also goes for three-membered ring. And benzene type of ring system will also prefer to form three-membered rings when it's going to be attacking as a neighboring group there.
Yeah.
Okay. Now, any other ring sizes which I've forgotten? It's been a while since I've taught this shit, so I might have forgotten some of them. Any other ring sizes you have discussed in school?
No, sir, we heard about it.
Okay. And this is a nonsensical thing actually. This benzene ring crap. Why I gave this is because stupid little MS Chauhan questions will have this shit.
Yeah, it had.
There is that's the only reason why I'm giving this crap. It doesn't. It's nonsense. Yeah. Sometimes just gets frustrating when you see Indian authors purposely giving every possible nonsense. But chalo, he is now doing that. I saw the JEE mains papers, the questions which have shown up. They are not exactly tough, but they are asking nook and crannies more and more and more now. Organic method is easier only. Inorganic is getting very interesting. At least the parts of inorganic which are there in the syllabus are fairly interesting this time. They've definitely asked some good questions. How was the result in your campus?
So I think we got 199.98, I guess. Uh,
Yeah. Total में
no, the best in our campus is 99.98. I think he got like 275 or something. Something like that. 280 to 75 something like that.
that's a good score, huh?
Yeah. And
And
then CM batch one guy got 300. Yeah. I told you
yeah,
also.
yeah, one guy got 300, right?
Yeah. And two got 290 plus.
Not bad. That is the Madhapur batch. Yeah,
Madhapur. Yes, sir. Yeah.
not bad. But problem is the same equivalent campus in Narayana got 4. And I think they had like around 4 300s and maybe 3 or 4 or 5 295 के आसपास. So Fiji has done well. Fiji has done quite well. At least Hyderabad has done quite well. Chaitanya से तो ज्यादा किया है. Chaitanya तो वाट लगाता है इस बार. And surprisingly, they are supposed to have better students this time. I'm quite surprised with what has happened. Chaitanya, from what I know, they are scrambling badly. No, I really mean they are scrambling badly. In a sense, one of my old friends is working in Chaitanya's main campus here. So the dude was telling me they are trying to buy students now. I was like, what the already सोच रहे हैं वो. I can understand that when the game is like really turned around, but there's one more round left over. And very sobering reality. All right, next question.
1 second. Yes. Sir, when we're talking about leaving groups, like what makes a good leaving group? Like in one NGP question, I like I'll just tell you the question. So it's cyclohexane with at 1 and 2 there is C3S and Cl.
C3,
S.
CS3, yeah, C3.
CH3S, my bad. CH3S, my bad. Sorry. And then chlorine, which are anti to each other.
CS3?
No, CH3S.
CH3S.
Yeah, and chlorine are anti to each other on
Send
cyclohexane.
Send the photo.
Okay.
My brain is not able to comprehend it properly. Sorry.
Yes, sir.
What the hell is CH3S? Is it CH3?
Yes, CH3.
Okay, it's a thio ether type shit. Okay.
Yeah.
What's the issue here?
So like I know that like chlorine would leave, but then why wouldn't CH bond break rather than Cl bond? Like I think
which bond break?
said when this thing attacks, one bond must be lost by the carbon, which is the C delta plus carbon, right?
So what you have basically got here is something like this. We have an SCH3 here, and we are having something like this. So the issue here is this bugger might come and attack here, and this might leave.
Yeah.
So what's your question now here? Let me mark them, number them here. 1, 2. Okay, and in this particular case here, what is the other substance which is put in?
OH minus.
OH minus. Okay, so if I am putting in OH minus, let's say the neighboring group participation does. After it has happened, the sulfur will basically form a 3-membered ring. But this time the sulfur will be with a positive charge.
Yes.
Something has to break now.
Yeah.
So which is more susceptible for attack now?
for attack.
Hmm. To get attacked by the OH minus, something has to attack the system, no?
Oh, that's what you mean. Okay. Yeah.
So let's say we are having this. Somehow this has formed.
Yeah.
This guy has a positive charge now.
So
Where
what
will
about the
minus
chlorine?
attack?
The chlorine?
Hmm?
The chlorine.
There is no chlorine. Chlorine is left. If neighboring group participation happens, chlorine left, correct?
Yeah, correct. But
Hmm.
okay, fine.
Where will the attack happen now then?
On the carbons,
Which carbon?
the attached to sulfur.
102 or CH3?
1, 2. Yes.
The attack has to be SN2 type.
SN2 type. Yes.
What will be the factors to consider?
Steric hindrance. Then
Which guy is my leaving group now? Sulfur is a leaving group.
yeah,
So which fellow will get attacked?
the methyl CH3.
Correct. So now, logically, if neighboring group participation should happen, methyl should get targeted here.
Okay.
What was the issue here? What was your question here? Let's
Yeah.
go back to the question.
So this. Yeah. Where would the this thing attack? Which man is like CH3 or like that?
That should attack the CH3. If the OH minus does attack this system, which is formed here, if the OH minus attacks this system, this molecule, or this system, if neighboring group participation has happened, if I have had this system formed, if OH minus attacks here, it will attack this guy. It will not go for these two. Simply because steric hindrance is much higher here. OH minus has to do SN2 type attack only. Why the hell would it prefer to attack the all of them are alpha to the sulfur plus?
Yeah.
Any one of them can basically be targeted then.
Exactly. Yeah.
Sulfur just needs to leave its positive charge.
Yes. Yeah.
So
So
where will
then,
it
what will be the product? Can you?
see? The product here is going to be something which will be the ring there with the three-membered ring. But the problem here will come is that three-membered ring acceptable? So
For
if
sure.
that three-membered ring was given as one of the options, I would pick that. If this is going to be some kind of general, what to say, question where you
No
have
options.
to go with whatever you want to go with, then you give all possible options. Organic chemistry, may if they are giving you something where it's a general question, you should not basically limit yourself saying ki yehi hoga. You go with everything which can happen. If they are giving you options, you pick the best.
Okay. Yeah. Mhm.
Option wala question hai ki kya hai?
No, sir. Just a general question.
General question, I will go with the three-membered formation there. I will also be giving the other possible attacks.
Yeah, attacking 1 and 2.
Hmm. Attacking 1-2 will not be that great there. I actually go with OH minus directly going and attacking the fellow
Sulfur.
there. That is actually a more possible thing because yes, neighboring group participation can happen here, but sulfur will not prefer attacking, not that easily.
So initially, why is the OH minus attacking the sulfur? Because you said negative charge was formed, right?
Because there is no chance of forming a negative there, na? It is a thioether, right?
Yeah, correct. But then it could take the OH CH3 away initially, right?
What?
Oh, my bad. Said nothing. I don't know. Wait.
This is a thioether system, right?
Yes, sir. Yeah.
Then there is no way this guy can get a negative.
What?
It can't get a negative. How can sulfur get a negative? It is attached to two carbons, right? And the sulfur is a shitty leaving group. It
Yeah,
doesn't
and CH3 can't
go
even
to
leave.
the leaving group part there. When is it? What is a good leaving group? A good leaving group is something which is going to be stabilized in the solvent when it is leave. Once it has left. So in this particular case, the sulfur will simply not leave. The
Mhm.
chlorine minus is going to be a far better leaving group compared to the sulfur there. So OH minus will simply not attack one of the carbons attached to the sulfur in the first place. If that's what your issue was.
Okay. Okay, sir. Yeah. I got my answer.
What was the answer given? I am curious.
Sir, 1 and 2 was given, attacking 1 and 2.
After NGP?
Yes, sir, yeah.
No, I will not. That is not logical. That is
Okay.
just somebody playing bullshit there. If they've
Okay.
not even considered the possibility of the methyl getting targeted, yeah, that's what I would say.
Yeah, was not considered.
Next. Methyl is definitely going to be a much better possibility than 1 and 2, simply because of the fact that if it has to be attacked, you have to consider steric hindrance. And all three of them are alpha locations to my sulfur plus. So if
Hmm.
ring fellow is formed, yeah, if this guy is definitely formed, I would say the methyl location getting targeted is actually slightly higher probability than the other two.
Okay.
Next.
Yes. I have a few.
So you have only doubts in random questions like this, or do you have doubts in theory as well?
No, I have doubts in like questions, like
Yeah,
in
all right.
film.
See, in questions, if you're going to be asking questions which are like open-ended like this, you're giving me a lot of room to escape, and you have to
Okay.
understand.
Yeah.
Give options that will make it more
Yeah, now
what
I'm
is
sending options. Sir, yeah.
cut throat, so to say. That will give you better answers as well. Because you are never going to be asked organic chemistry questions in a 100 fashion.
Yeah.
Nobody will do that. If they're doing that, they are just pulling the wool over your eyes. That is not going to happen.
Hmm.
You're not preparing for goddamn Olympiads, for God's sake. You're preparing for JEE.
Yes. Yeah.
Now, question with what is the major product obtained in the following reaction? What's your issue here?
Sir, I if
This is a
the
very easy question.
sir, what?
This is a very easy question.
Yeah, I know, sir, I know. But then why won't the OH attack? That's my doubt. Like why this why would the NH2 attack rather than the OH? Like that could NH3 could also act as a solvent, right?
Okay, okay, okay. Sometimes the questions you ask, dude, are unnecessarily stupid. Okay,
Like,
now
I got the answer.
stop. Let's go for understanding basicity and nucleophilicity first again. Now, if I'm going to be considering basic character, nitrogen ending, oxygen ending, which is a better base?
Nitrogen.
Wonderful. So ammonia and water or ammonia, ethanol, ammonia is a superior base.
Yes.
Okay. So which should attack from basic character point of view?
NH3.
Good. Now, next, if I'm considering from nucleophilic character point of view, when is a substance a better nucleophile? When that
um
substance is more easily approachable, it's a better nucleophile.
yes, yeah, that's it.
So when you consider approachability, what does approachability mean? If I have, say, a system in a solvent, which is polar protic, like in this case, the polar protic fellow is going to be surrounding the location with the delta plus or delta minus with the opposite fellow there, correct?
Yes,
If I
sir.
consider water, what is the role of water? How does water make something a weaker nucleophile? Why do
Accumulates.
we prefer polar aprotic for SN2? You know that we prefer polar aprotic for SN2, correct? Why?
Yes, sir,
Why?
because if it was polar protic, then the water molecules would accumulate around the thing.
Accumulate around what? The
The
delta.
nucleophile. Yeah.
And which part of the water molecule will accumulate?
The hydrogen.
Correct.
Hydrogen bond will.
So the hydrogen being smaller will accumulate around the delta minus or the nucleophilic center, which will prevent the other fellow or this guy to go attack more comfortably. Right?
Yeah.
When will the accumulation be more?
When it's smaller.
Hmm?
Smaller.
Is smaller the matter, or is delta minus the more important factor?
Oh, delta minus.
Right?
Yes.
So that delta minus depends on what? How electronegative that location is.
Exactly. Yeah. Yes.
Right? So we again go back to electronegativity. If the location which is going to be acting as a donator is less electronegative, it will inevitably be a better nucleophilic system as well. That is why in the phenoxide ion case, I mentioned that the ring is a better location as a nucleophile. You remember this phenoxide ion case?
Yes, sir. Yeah.
Why did I mention the ring is better? Because the carbon will be less solvated. This O minus ending here is going to be much more solvated. Whereas these locations are not going to be that well solvated.
Yes, sir. Yeah. Yeah.
Because the ring will repel any oxygen nearby. Hydrogen to aayega, but ring will repel the oxygen flow of far more. And you are having these locations being much less electronegative
Yes, sir.
because they are carbons, which means they don't attract that many water molecules in the first place.
Yeah.
You understand the idea here? Huh? So now you tell me which among the two is more preferred.
And it's
From either way, whichever way you look at it, the nitrogen is better, right?
yes, sir. Yeah. So, but
So
then there's a chance of us also attacking it. I mean, slight
there is no
minor.
chance. But why would you care about that
Yeah.
as a possibility?
I'm just okay. Yeah.
Now,
Okay.
what is among the other options given there in the question? Do you have a problem?
No, sir. No, no. I got the answer. But yeah.
You understand that the ring will not be touched, right?
Yes, sir. I won't be touched. Yeah.
So that bromine on the ring is not going to be hit at all.
Exactly. Yeah.
That part
Yes.
is clear, right?
That'll stay similar. Yes.
Cool. Okay, next.
1 second.
Have you started having fun with questions?
Slightly. Yeah. I completed like a decent amount in this.
Because ultimately that is the way to measure your progress, I would say. Your
Yeah.
actual progress.
Then yeah. Yes.
How are your previous chapters?
Uh, like hydrocarbons is a little weak. I still have to practice questions in that. I haven't done many.
Hydrocarbons, I'm quite sure they would have done what to say, elimination, internal, all of that nonsense.
Yes, sir. They,
The ester wala elimination, all of that crap has also been discussed, I'm sure, in your school.
yes, yes,
You've done those, I suppose.
yes, sir.
And you're clear with them?
Uh, the EI part, I am like I not that clear
They
on
did
it.
the amine oxide or they did the ester one or both?
So amine oxide, they did, I guess. Yeah.
Hmm?
Amine
Amine,
oxide. Yes, sir.
amine oxide they did. Ester one did they do or only amine oxide?
I don't remember them doing this.
Okay, all right. Ask your doubts, then I'll poke.
Okay, sir.
Normally, in the last 2 3 sessions, I've been leaving you with more what to say vagueness than clarity. I
Yes, sir.
will at least leave you with more clarity this time.
Okay.
So,
Yeah.
huh.
So like we started aryl halides yesterday, so I think metal Vignas age will have.
So alkyl halides, aryl halides, and then Grignard, and they close.
Yeah,
So
I
I'm
believe
for
that will be.
inositors also then.
No, sir. I don't like. We'll have online classes in April, but I don't think they'll complete that and give it for the exam.
Oh, छुट्टी है क्या तेरा?
Yes, sir. Yeah.